Hi, so today we're looking at Pearson Edexcel Functional Skills Maths Level 2. We've got past paper 5 and we're going to start with the non-calculator section. Question 1. Gareth sells hot drinks. He sells cups of tea, cups of coffee and cups of hot chocolate. Of all the hot drinks he sold last week, 2/5 were cups of tea, 1/3 were cups of coffee. What fraction of all cups of hot drinks sold were cups of hot chocolate? So we've got either tea, coffee, hot chocolate. So if 2/5 were tea and 1/3 were coffee, the rest must be hot chocolate. Okay, so what we can do is, if we add together the amounts of tea and coffee, the rest is going to be hot chocolate. So the first thing we're going to do is add together 2/5 and 1/3. So what we can think of it is like we've got 2/5 plus 1/3 plus something, which is going to be the hot chocolate is going to be the something, is going to be equal to 1. Because 1 is going to be the total. If you've got half of something and another half, the answer is going to be 1. So if we've got the proportion that are tea, proportion that are coffee, proportion that are hot chocolate, it's going to add up to 1. So if we can work out what this 2/5 plus 1/3 is and take it away from 1, we'll find out what the fraction is for hot chocolate. But the first problem we get here is when we're adding fractions together, we need the denominators to be the same, and they're clearly not. So what we say is, does one of the denominators go into the other? Can we divide 3 into 5? Well, no, not without having a remainder. So that means we need to find a denominator they both go into, so both denominators are going to have to change. So what's a number that's a multiple of 5 and 3? Well, I know that 3 times 5 is 15. So what we can say is we can rewrite this as a fraction over 15. Because we know 5 goes into 15 and 3 goes into 15. Now 5 goes into 15 3 times. So that means we need to multiply the 2 on top by 3 to get 6. And we've got a plus. Now the 3 goes into the 15 5 times. So that means we're going to need to multiply this 1 on top by 5. So we're going to get 6 plus 5 over 15. Well, 6 plus 5 is 11 over 15. So that's the total of tea and coffee. The rest are hot chocolate. Well, if 11/15 are tea and coffee, hot chocolate must be the rest. Well, 15th, so there's 15 altogether. If we take away the 11, we're going to be left with 4. But it's not just 4, it's going to be 4/15. And so we can put that in the box down here. Question 2. Work out 13.4 times 5.2. Okay, so we're going to do this using the column method. So 1, 3, 4, 5, 2. So I'm completely ignoring the decimal point for now. We're going to add that back in later on. So we're going to start off with the units. So we're going to do 2 times 4 is 8. Now 2 times 3 is 6, and 2 times 1 is 2. Now moving on to the tens, so we're not going to have any units. So now we've got 5 times 4, 5 fours, 5 fours, so we'll do 4, 8, 12, 16, 20. So put the 0, carry the 2. 5 threes, 3, 6, 9, 12, 15. Add the 2, 16, 17. And then 5 times 1 is 5. Add the 1 is 6. Now we need to add these together. So 8 plus 0 is 8. 6 plus 0 is 6. 2 plus 7 is 9. And 6 plus nothing is just 6. But we're going to work out where to put our decimal point. Now, we had one decimal place here and another decimal place here. So that's 2 decimal places altogether. So we're starting at the end with the decimal point 1, 2. So our answer is going to be 69.68. We've got a part B to this question. Use estimation to show a check of your working. Okay, well, we can say, well, 13.4, well, that's approximately equal to, well, let's round it to the nearest whole number. Well, 0.4, it's less than 5, so it's approximately equal to 13. And 5.2, well, that's approximately equal to, so again, round to the nearest whole number. 0.2 is less than 5, so we'll just round that to 5. So that means we've now got 13 times 5. So this is a bit simpler to work out. So 5 times 3, so 3, 6, 9, 12, 15. 5 carry the 1. And 1 times 5 is 5, add the 1 is 6. So we've got 65. And we can say, well, that's approximately equal to 69.68 because we've rounded it. So that's fine as a check using estimation. Question 3. Mitch works in a fitness centre. He gives one raffle ticket to each of 1,000 people that attend the fitness centre. Mitch starts to complete this two-way table to show information about the people he gives the raffle tickets to. So this table here, we've got the information split by the type of their favourite class. So either spin, yoga or cardio. And then we've got the totals. And we've also got it split by age, 18 to 24, or 25 to 49, and 50 and over. So in other words, if someone's favourite class is yoga and they're aged 27, it'd be yoga, 27, they'd be included in this cell here. Now, we would expect there to be numbers or at least zeros in all of these fields. So we've got to work out what the missing numbers are. So with these, what you want to do is look for a row or a column that's only got one number missing, and then use that to work out what the missing value is. So in other words, if we're looking at spin, I know that this plus this plus this must equal 230. Okay. Now to work out what the 18 to 24 value is, what I can do is start off by adding these two numbers together. So if we do 107 plus 38, 7 plus 8 is 15, 0 plus 3 plus 1 is 4, 1 plus nothing is 1. So we know this total is 145. If we want to know what this value is, well, we need to take the 145 away from the 230. So 0 take away 5. Well, you can't take 5 away from 0. So what we're going to have to do is take 1 from here, reduce the 3 to a 2, and pass the 1 across. So now we've got 10 take away 5 is 5. 2 take away 4. Well, you can't take 4 away from 2. So we're going to take 1 from here, reduce that to 1. And the 1 we've taken, we're going to put in front of the 2. So we've now got 12 take away 4, which is 8. And 1 take away 1, that's nothing. So this must be 85. Now we're going to do something similar for yoga. If we can find out what the total of the 18 to 24 and the 50 and overs is, we can use it to work out this missing age group here. So we're going to do 92 plus 170. 2 plus 0 is 2. 9 plus 7 is 16. 6 carry the 1. 1 plus 1 is 2. So these two added together is 262. If we want to know the missing number, we need to take it away from 381. So 381 minus 262. 1 take away 2. Remember, every time the number we're trying to take away, if it's bigger, well, then we're going to need to reduce this by 1 and pass the 1 over. So now we've got 11 minus 2 is 9. 7 minus 6 is 1. And 3 minus 2 is 1. So we can put our missing number in here. Now this value here, we could do the same sort of thing again, but actually instead of adding these together and taking away, we could just add these three numbers together to get the total. So I think I'll do it that way. So let's move it up a bit. So we're going to say 107 and 119 and 134 all added together is going to give me this answer. So 7 plus 9 is 16, plus 4 is 20. 1 plus 3 is 4, plus 2 is 6, and 1 plus 1 plus 1 is 3. So 360. Don't worry if your adding up isn't quite as quick as the way I was doing it there. If you need to use your fingers, if you're counting on, it's absolutely fine. As long as we're getting the same answer there. Now, all we need to work out is our cardio missing value now. So there's more than one way to do this. But the way I'm going to do it is I'm going to add these two together and then take them away from the 389. So we want 145. Plus 134. 5 plus 4 is 9. 4 plus 3 is 7. 1 plus 1 is 2. So we've got 279. So we want to take the 279 away from the 389. 9 minus 9 is 0. 8 minus 7 is 1. 3 minus 2 is 1. So we've got 110 in here. So now we've got all of our values completed. Mitch selects a raffle ticket at random. What is the probability that the ticket he selects belongs to a person aged under 50 whose favourite class is cardio? It's a probability question. So we're going to give our answer as a fraction. Now, it's always good to start with the denominator. So Mitch selects a raffle ticket at random. So that could be anyone. Now, how many raffle tickets did we have in total? Well, we've got 1,000. So I can put that as my denominator straight away. Now, which people are we interested in? Well, we're interested in a person aged under 50 whose favourite class is cardio. So under 50 cardio. Well, these are my cardio people. We want under 50. Well, these are 50 and over, so we don't want these. So we want these two, which we've actually already worked out as 279. So our answer is going to be 279 over 1,000. Now we could try to simplify. I'm not sure if it simplifies, but they haven't asked us to, so I'm just going to leave it like that. Question 4. Dave is going to paint a wall. Here is a scale diagram of the wall. And we're told that scale is 1 centimetre represents 0.5 metres. Dave will paint this wall twice. He thinks the total area that he needs to paint is greater than 30 metres squared. Is Dave correct? You must show all your working. Okay, now, they haven't told us the measurements, but they've told us the scale. So what we need to do is actually measure the distances. Now, because this is a sample paper, and we've got the way it's printed out with these extra do not write in this area columns added, it means that the paper sort of shrunk down. So if I measure across here, for example, so 6.2 or 6.3 centimetres. But actually, I know that on the real exam paper, had you received it, it would measure as 7 centimetres. Okay, and this one here, which comes out about 7 or 7.1 centimetres here, again, if you received the exam paper, it would be 8 centimetres. And this bottom one, which is about 10.7 centimetres, on the real exam paper, it would measure as 12 centimetres. So if you've worked it out using the accurate measurements, well done first of all, and because it will be a lot more difficult because you've got decimals in there. But I'm going to show you the answers using the measurements if you'd had it in the exam, and that will then give you the answers that will tie up with the mark scheme as well. Okay, so imagine that we know we've got these distances. First thing we're going to do is apply our scale. Well, if 1 centimetre represents 0.5 metres, well, it might be easy to think, well, 2 centimetres would represent 1 metre. So if we start with here, for example, 8 centimetres, well, if 2 centimetres are 1 metre, so 2 cm represents 1 metre. Well, 8 centimetres, that's like 2, 4, 6, 8. So that's going to be 4 metres. Okay. So similarly here, 12 centimetres. How many lots of 2 centimetres have we got? We've got 2, 4, 6, 8, 10, 12. So that's 6 lots. So it's going to be equal to 6 metres. So in other words, it's half of the answer. So if we want half of 7, well, half of 7 is going to be 3.5 metres. And if you want to see how you do that, well, if you want 7 divided by 2, we can do it using the bus stop method. Well, how many times is 2 going to 7? 2, 4, 6, that's 3 times. But we've got 1 left over. So what we can do is put our point 0 and carry the 1. And put our decimal point up here as well so it lines up. How many times is 2 going to 10? 2, 4, 6, 8, 10. That's 5 times. So that's our 3.5 metres. So we've got our measurements. We've now converted them to metres using our scale. Now we need to work out the area. Now what you could do is you could split this shape into a rectangle and a triangle. But actually if we look at this, what shape is it? Well, it's got 1, 2, 3, 4 sides. It's got 2 parallel sides. So I know that this shape is a trapezium. And I know a formula for working out the area of a trapezium, which is A plus B divided by 2 times H, where A and B are the parallel sides, so we can call this A and this one B, and H is the height, so down this way, so this is my H. So in other words, we've got A, which is 3.5, plus B, which is 6, and then we're going to divide that by 2 and multiply by the height, which is 4. So let's do this. So 3.5 plus 6. Well, let's give us a point 0 so we've got something to add to. 5 plus 0 is 5. Decimal point. 3 plus 6 is 9. So we've got 9.5 divided by 2 times 4. Okay. Well, what we can do with this, instead of dividing the 9.5 times 2, you can think of this as, well, it's like 9.5 times 4 all divided by 2. So it doesn't really matter which of these numbers is divided by 2. So what I'm going to do is I'm going to do this as the divide by 2. So in other words, I'm going to keep my 9.5 and say, well, 4 divided by 2 is 2. So it's like we're cancelling out the 2 here. So in other words, we're ending up with 9.5 times 2. So 2 times 5 is 10. 0 carry the 1. 2 times 9 is 18. Add the 1 is 19. And I had put the decimal point in, but if you think we've got 1 decimal point, so we're going to bring it back in there. So we're going to have 19, so that's going to be 19 metres squared. Right, now we don't want to stop there, because they said that Dave will paint this wall twice. So 19 metres squared is just the area of the wall. If he's going to paint it twice, we want 19 times 2. 2 times 9, 9, 18. Carry the 1. 2 times 1 is 2. Add 1 is 3. So we're going to have 2 times 19 is 38 metres squared. Okay, he thinks the total area is greater than 30 metres squared. Well, 38 metres squared certainly is greater than 30 metres squared. So, is Dave correct? Yes, he is. Okay. And that's the end of the non-calculator section. So we've got functional skills, maths, Edexcel level 2, past paper 5, and now we're going to look at the calculator section. Question 1. Here is a set of data. Find the median. Well, if I want the median, I find the best way to do that is to sort all my numbers in ascending order and then find the middle one. So let's rank them first. What's the smallest? Well, the smallest is 0, so that can be number 1. What's the next smallest number? Well, it's 8. Doesn't matter which one, so that can be 2, 3, 4. What's the next smallest? 10, I think, so it's 5. Then we got 15. 13, I think, is next smallest. That will be our 6th number. 14 will be our 7th. 15, we've got 2 15s, so it can be the 8th and 9th. And finally, 16 is our 10th number. So now I'm going to rewrite them using this order. So the smallest was 0, then we had 8, 8, 8, then we had 10, 13, 14, 15, another 15, and a 16. So for the median, we can cross off the smallest and the largest. Next smallest, next largest. And keep going until we end up with either 1 or 2 in the middle. Okay, so we're always crossing them off in pairs. Here, 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 here. Now, because we've got 2 left in the middle, we need to add them together and divide by 2. Well, we can do this with the calculator. So 10 plus 13. Make sure we do equals first. So we've got 23 divided by 2, which gives us 11.5. And that looks sensible because it's between 10 and 13. If we got a number outside that range, we would know that something was wrong. And then for part B, find the mode. Well, the mode is the number that occurs the most amount of times. Now, by sorting it, this has kind of helped because I can quite quickly see we've got 2 15s, we've got 1 of all of these numbers, we've got 3 8s. So 8 is the number that occurs the most. So that is my mode. Question 2. Last year, Jim bought 15 prizes for work. The prizes cost £27 each. This year, Jim will buy 18 prizes. He will spend the same total amount of money as he spent last year on the prizes. Each of the 18 prizes must cost the same amount of money. Work out the cost of each prize this year. So, last year he had 15 of them at £27 each. So, altogether, he must have spent 15 times 27, which is £405. Now, if he wants to split that evenly among 18 prizes, we're going to do 405 divided by 18, which gives us 22.5. But this is money, so we need a pound sign, and we can't have 0.5 of a pound. We're going to turn it into 50p. Question 3. Steve is writing a report about TV viewing. He has the following information. So the number of people in the household and the number of TVs in the household. So we've got, if there were 3 people in the household, there were 2 TVs. Another house had 5 people in the household, they had 3 TVs, and so on. Steve thinks there is a relationship between the number of people and the number of TVs in a household. Draw a suitable diagram for Steve. Well, they're talking about relationships and 2 different variables here, so we're going to be talking about a scatter diagram. Okay, and we've got our graph paper here. So it's always good to go with, you don't have to, but it's fairly standard to go with whatever comes first. Write it along the bottom. So we've got number of people in the household. So that's going to go down here. Number of people in household. And what does that go up to? Well, the biggest number is 6. Well, let's see how many of these big boxes we've got. 1, 2, 3, 4, 5, 6. Perfect. So we can have one big box for each number. So we said that that was 6, didn't we? 6, 5, 4, 3, 2, 1. And we want to be starting at 0, so that's good. So that's the number of people in the household. Now we've also got number of TVs in the household. And the biggest number we've got here is 5. So if we're starting down here, number TVs in household, we needed to go up to 5, didn't we? So let's look at these big boxes again. 1, 2, 3, 4, 5. Yeah, that's going to fit on just nicely. Again, we can draw this on. 5, 4, 3, 2, 1, and make sure we go down to 0. Right, so we've got to plot each of these values. So the first one is 3 in the household, 2 TVs. So 3 in the household, we go along 3, 2 TVs. So we can put across there. The next one was 5 in the household and 3 TVs. So 5 in the household and up to 3 TVs. The next one we had was 5 in the household and 4 TVs. So along to 5 and up to 4. Now I'm not going to keep moving it up and down. The next one we had was 6 people in the household and 4 TVs. So 6 and 4. Then we had 5 in the household with 5 TVs. 2 in the household with 1 TV. 4 in the household with 3 TVs, and we had 2 in the household with 2 TVs. Okay, so those are the values, and we get something that looks like this. Now, all that's missing at the moment is a title, so we can just call it TV viewing. And there's our scatter diagram. Now we've got part B here, which tells us or asks us to describe the relationship between the number of people and the number of TVs in a household. Now it's quite hard to see just looking at the values. So what we can do, what's always good with a scatter diagram, is to draw a line of best fit. So we want a line that follows the overall pattern, so going up like this, and we want the line to be roughly between the points. So you've got about the same sort of number of points above the line as below the line. So something like that. Yeah, I think that looks reasonable. Doesn't matter if it goes through some of the points, it doesn't matter if it doesn't. It's just following the overall pattern and roughly in the middle. Okay, so we've got our line of best fit, but it's asked us to describe the relationship. Well, we would call this, because as the number of people in the household goes up, so does the number of TVs. So we'd say it's a positive. Well, they've said relationship. We could say a positive correlation otherwise. Okay, question 4. Karen invests £2,500 for 3 years. The investment earns 1.7% compound interest per year. Work out the value of the investment at the end of 3 years. Right, well, you might remember the formula for this, but I like to try and work it out sort of using a bit of logic and reasoning. So what we're going to need to do is first turn this percent into a decimal. So we want 1.7 divided by 100. And we get 0.017. So if we're working out just the interest for the first year, we'd multiply equals by 0.017. But what we want to do is we want to increase it by this amount. So we want 100% of the original plus this. So in other words, we want to add 1 to it. So if we add 1, we get 1.017. Okay, so that means that if we take our £2,500 and we multiply it by 1.017, the answer is going to have still the original 2,500, but it's going to add on our 1.7% of interest. Now, because we're doing it for 3 years, we don't just multiply it by 1.017 once. We do it twice and 3 times. So we can put that in our memory. So we're saying 2,500 times memory recall equals, times memory recall equals, and times memory recall, or you can type it in each time, 1.017 equals 2629 point, well, 2 decimal places will be 67, but this is a 9, so we're going to round up to 68. Put that in there and give it our pound sign. Now, if you had a scientific calculator and you were using the formula, you could go straight with 2,500 times 1.017 to the power 3, which is exactly the same as what we're doing here. Okay, but just showing it doesn't matter if you do it with a simple calculator or scientific calculator, you should get that same answer. Question 5. Here is a cylinder. Okay, here's a cylinder standing up. And we got this measurement here of y centimetres and this measurement across here of 3y centimetres. Using y equals 11, calculate the area of the curved surface of the cylinder. So in other words, it's talking about this bit here, but going all the way round. So because it's going round, we actually want to know what the circumference is. And I'm hoping you remember that the circumference of a circle, that formula for it is, well, you might remember it as 2 pi r, where r is the radius, or pi d, where d is the diameter. Now it doesn't matter if you remember it as 2 pi r, because all you do is you divide this by 2 and then you double it again. So you're going to end up with the same answer. So whichever way you do it is fine. But because we've already been given the diameter, we can go straight with this version of the formula. Now, before we apply the formula, we're told that y equals 11 centimetres. So I can substitute that straight in there. So that's 11 centimetres. This one is 3y. So it's going to be 3 times 11, which you can use your calculator, but hopefully you can do 3 times 11 is 33 centimetres. So that means that the circumference is going to be pi. And if you look at the front of the paper, it'll tell you to use 3.14 for pi. And the diameter is given here of 33 centimetres. Okay, so if we do our calculator, 3.14 times 33 gives us 103.62. Okay, and that's centimetres because it's the circumference. Now that's the distance round. Now, because it's the area, we actually want to multiply it by this height, because we want to know, well, how wide is this sort of tape or whatever it is that's going round. So we're going to need to multiply this by the height, which is 11. Which gives us 1139.82 or 1139.82, and its area, so it's centimetres squared. Now, we've got a second part to this. Here is a trapezium. The trapezium has one line of symmetry. Okay, what if it's got one line of symmetry? I'm guessing it must be straight down the middle like that. Choose the correct calculation to work out the perimeter of the trapezium. Right, well, the perimeter is the distance around the outside. Now, looking at these distances, or particularly the units, we've got centimetres here, we've got millimetres here. So we wouldn't be able to just add these numbers together. Okay, for perimeter, we add them all together. So we can't add these ones. So in fact, what we'd want to do is to convert that. So although it's asking which is correct, I'm actually working out what the calculation for the perimeter is, so then I can compare it to any of these answers. So I know that we've got 10 millimetres in 1 centimetre. So if I want to, I can either convert the 2 centimetres into millimetres or the 1 millimetre measurement into centimetres. Because I've only got one of these, I'm going to convert it to centimetres. So we want to divide it by 10. And we can use the calculator. 150 divided by 10. You just take the 0 off and you get 15 centimetres. Now, because we've got a line of symmetry, it means that this measurement over here must also be 15 centimetres. So actually what I'm expecting is to see something that is something like, well, adding all of the measurements, so it would be like 28 plus 15 plus 45 plus another 15. Okay, so let's have a look if we've got anything like that. Well, 28 times, well, if it's perimeter, we don't want to have times, we want to have plus. So that's no good. This one, 28, we're doing some adding, but we've got a bit of a mixture. We've got 28, which looks good, but then we got 150. So we've got a mixture of centimetres and millimetres. That's no good. We've got another multiplying one. That won't help me in perimeter. We have got some adding here. Now, we've got an extra 0 on the end, but we've got it on all of them. So in fact, what they're doing here is they're adding them, but they're doing them all as millimetres, which is fine. So this is looking quite good because they would all be consistent. If I turn these into millimetres, I'd multiply them all by 10, which would be like putting a 0 on the end. So I'm liking this one at the moment. Let's just check this. Well, no, this is doing multiply again. So, yeah, I definitely like answer B there. Question 6. Write 45% as a fraction in its simplest form. Well, as a fraction, 45% is 45 divided by 100. That'll get us that's half of the way there. We need it in its simplest form, so we've got to find a number that goes into both 45 and 100, or a common factor. Well, I know if a number ends in 5, that it's divisible by 5. And also if a number ends in 0, it must be divisible by 5. So we're going to divide both of them by 5. But we can use our calculator to do this. So 45 divided by 5 is 9. And 100 divided by 5 gives me 20. And I don't think I'm going to be able to get any simpler than that. I think that's as far as we can go. Okay, so I can just write that in here. If you wanted to, you could check. Well, they're not both even, so 2 won't go into it. 3 goes into 9, but it doesn't go into 20. So you can try, but this is simple, or as simplified as it will go. Okay, part B. Calculate 5 plus 13 squared, all divided by 11 minus 9.5. Now on this one, although they haven't done it, because we've got the divide sign here, it's like we've got brackets, because we would do everything at the top first and everything at the bottom first. Now within the brackets, so we're looking at just the top on its own. We've got a plus, but we've also got a squared here. So we would do the squared first. So the 5 is going to stay, but we want to know what 13 squared is. Well, that's 13 times 13, which is 169. Okay. At the same time, the bottom, well, because this is sort of in brackets, we can do this now. We don't need to wait for the answer to the top. So we can say 11 minus 9.5, we get 1.5. Now for the next step, we can't do the divide yet because we've still sort of got these brackets up here because it's still at the top half of the fraction. So we can do our 5 plus 169 to give us 174, and that then needs to be divided by 1.5. And if we do that, we get an answer of 116, which we can put in our answer box down here. Question 7. Kate is making biscuits. She uses flour, butter and sugar in the ratio 5 to 3 to 2. Kate has 800 grams of flour, 500 grams of butter. Kate wants to make the maximum number of biscuits possible. She works out how much sugar she needs. How much sugar does Kate need? You must show you're working. Right, so we've got this ratio. So let's start by writing our ratio down. So we've got, I'm going to draw a simple table here. We've got flour, butter, sugar, and we've got a ratio of 5 to 3 to 2. Well, what do we know? We know we've got flour of 800 grams, and we've got butter of 550 grams. Now, what we can think about is she wants to make the maximum number of biscuits possible. Well, let's think about the flour first of all. If we had 800 grams of flour, how many times this ratio can we do if we had 800 grams of flour? So in other words, what is 800 divided by 5? 160. So multiply by 160. Okay, so it's saying just if we had 800 grams of flour, we could apply this ratio 160 times. Let's look at the butter. So let's do something similar here. If we're going, how many times does 3 go into 550? Or 550 divided by 3? Well, that goes 183.33333 times. Okay, but we can't actually multiply this ratio 183 times because we might have enough butter to do that, but with the flour we've only got enough to do it 160 times. So use this as smaller than the 183.3. Okay, so in other words, what we're saying is we're going to be doing this ratio 160 times. So we need to multiply the sugar by 160. So if we do 2 times 160, we get 320, and that's in grams. So we can put our answer in there. Okay, so we needed to work out which of the flour or the butter was going to be the most important one in using to work out how much sugar we needed. Now, we then asked for a check, and they said use a reverse calculation to show a check of your working. Well, a reverse calculation, that means we start with the answer. So we've ended with 320, so we're going to start with the 320 before we multiplied it by 160. So we're going to divide it by 160. And that takes us back to 2, which is what we had here. Now, what did we do in the other part of the calculation? Well, that's part of it. That would probably get you a mark. But also with the 800, we calculated that 800. And the way we got the 800 was by doing 160 times 5. So if we do 800 divided by 5, we should also get back to 160. So we sort of got almost 2 checks there. Question 8. Lou wants to go to a gym. She sees these 2 offers at the gym. Offer A, gym membership, £44 per month plus a £30 joining fee, all classes included. Or offer B, which is pay as you go. It just pays £7.75 per class with no joining fee. Okay, so this one might seem the more simple one, but is it going to be the cheaper one? So Lou wants to attend 2 classes each week for 1 year. Lou thinks if she uses offer A, she will save at least 28% on the total cost of classes compared to using offer B. Is she correct? Show why you think this. Right, okay, so let's think about our 2 offers. Let's start with offer A. So it's going to be £44 per month. So 44, there's 12 months in a year. And then there's a £30 joining fee. So 44 times 12 equals, plus the £30, gives us £558. Or offer B, pay as you go. So what have we got? She wants, it's £7.75 per class. We've got 2 classes per week, 52 weeks in a year, so it's going to be 2 times 52 to give us the number of classes, and then we're going to multiply that by £7.75. You could work this out first and then multiply it, but essentially we're multiplying these 3 together. So 2 times 52 means she's doing 104 classes in the year at £7.75 each. That's going to be £806. Now, Lou thinks if she uses offer A, she'll save at least 28% on the total cost. Okay, well, what we can do here is, well, we can work out what is the percentage that she would save. So if we want to work out how much she'll save, well, first of all, let's find out what the actual difference is between them. So 806 minus 558, sorry, 558 is £248. So that's the saving. So what is that as a percentage? Well, it's a percentage of what the total cost was. So it's going to be 248 divided by 806. To make it a percent, we multiply by 100. And we get a percentage of 30 point, we'll do it one decimal place, so 76, so it's more than 5, so we round up to 30.8%. She thinks she'll save at least 28%. Well, yeah, 30.8% is more than 28%. So is she correct? Yes, she is. Question 9. Here is a grid with points A, where's A, B, C and D plotted. And the first question is, write down the coordinates of point A. Right, so the coordinates, we always look at the X first, the going across. A is -7, and on the Y coordinate, -4. So, -7, -4. And the order of these is very important. If you put -4, -7, you will get nothing. On the grid, mark with a cross another point and join all 5 points to form a pentagon with one line of symmetry. Right. Okay, so we're going to have these joined up. We want one line of symmetry. Well, at the moment, what I'm going to do is I'm going to connect some of these points. See what shape I'm getting. Now I've got a slopey bit here, so I'm actually going to join them this way, because what I'm thinking is, I feel like I've got a line of symmetry going through the middle here. What if how this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, half of 10 is 5. 1, 2, 3, 4, 5. So I think they're talking about a line of symmetry. So I think we've probably got a line of symmetry which would go straight through the middle. We've got to find the extra point to make our pentagon. Now we've got 1, 2, 3 sides, so if we put a point somewhere, we'll have 4, 5. Now, so long as we put the point somewhere on this line, it doesn't really matter. I mean, I'm thinking to put it somewhere out here, but actually, I'm going to put it there, because I don't think this is what people will naturally think of as a pentagon. But it is drawn with straight lines. It's 1, 2, 3, 4, 5. So that's a pentagon. Okay, and it's got our line of symmetry, because if we fold this along this line, that would fit perfectly onto that side. Okay, and that's all they've asked us to do. To mark with a cross, and I've marked my cross there. I might even do an arrow to show you that's where it is. So across anywhere along this line. So we could have it here, we could have it here. Doesn't matter. Any of those is going to give us a pentagon with one line of symmetry. If we've got the cross higher than this line, so up here or down here, it's not going to work. Question 10. got Rav provides food for events. Last year, 550 people attended an event. This year, there will be 748 people attending the event. Calculate the percentage increase in the number of people attending. So we had something similar to this before. First, we want the actual increase. So it's going to be 748 minus 550. Which is 198. And it's the increase. So we're looking at the 198 divided by the starting number, which is 550. And because it's a percentage, we're going to multiply by 100. So 198 divided by 550 times 100. And we've got a 36% increase. Now we've got question 11. Meg has a dog. She has this information about dog food. So we've got different sizes of dog food. For a small dog, up to 12 kilograms, the daily quantity of dog food in packs. So you need between a quarter to 1 1/3 pack of a pack. For a medium dog, so that's between 13 kilos and 25 kilos, you need somewhere between 1 1/3 to 2 1/3 packs, and so on. Meg knows that her dog weighs 29 pounds, and we're told that 1 kilo equals 2.2 pounds. Meg has 24 packs of dog food. What is the maximum number of days, she can feed her dog with the 24 packs? Show why you think this. Well, the first thing we want to do is work out what the dog weighs in kilos so we can work out what size category it fits into. So 29 pounds, and we know 1 kilo is 2.2 pounds. So if we want to find the number of kilos, we need to find the number of times 2.2 goes into 29. Or in other words, 29 divided by 2.2. It might help to think of it as a ratio question. So if you think we've got kilograms and pounds, 1 kilo is 2.2 pounds. So for 29 pounds, what we're doing is we're saying, how do we get from 2.2 to 29, or 29 divided by 2.2? And then we're going to use that to multiply by the 1. So if we do 29 divided by 2.2, we get 13.18. I'll leave it as 2 decimal places for now. 1/8, that's less than 5, so that would stay there. I'm going to put it, I didn't mean to do that. 29 divided by 2.2. I'm going to put it in my memory, so memory plus, in case I need it later. Now, I'm not sure I will need it later, but there's no harm in saving it in there. If it's 13.18 kilograms, that's going to fall into this category. It's between 13 and 25 kilos. So it's a medium dog. Yeah. Now, all they tell us is that if it's a medium dog, the quantity of dog food in packs is between these two numbers. They want the maximum number of days that she can feed the dog. Well, if it's the maximum number of days, I'm going to go with the minimum amount of food that she needs for each of those days. Okay, so 1 1/3. So what we want to do is say, well, if we've got 24 packs of food, we want to know how many 1 1/3s fit into it. So 24 divided by 1 1/3. Now that might be a little bit fiddly to do. So what I'm going to do with this 1 1/3 is I'm going to convert it. Instead of being a mixed number, I'm going to convert it into an improper fraction. Well, 1 1/3, that's the same as saying like 3/3 for the 1 and an extra third, or in other words, 4/3. So what we want is 24 divided by 4/3. Okay, so what I think the way I will do this is say, well, I'm going to work out the 4/3 first. So 4 divided by 3, 1.333. I'll put that in my memory. And then I'll say 24 divided by memory recall, which gives me 18 packs. Sorry, not 18 packs, 18 days. Okay, so it's a bit confusing doing it this way. If you can think of an alternative, then excellent. But we're trying to turn this 1 1/3 into a nicer thing to deal with, which is why we went from a mixed number into an improper fraction. Now, I did this on the calculator. If you wanted to do this without, you can think of it as 24 divided by, you can think of it as 24 divided by 1 divided by 4.3, and then use KFC, so keep the first one, flip the second one, and change the divide to a multiply, and that will give you 24 times 3, which is 72, divided by 1 times 4, which is 4, which still gets you back to 18. So this is an alternative. So this is if you can't quite get your head around what am I doing with using my memory, or how am I trying to divide this. This is just to sort of show you what's going on. But essentially we're saying this is the minimum amount of food we need. We've got 24 packs, so how many times can I put that into 24 packs? Or how many times can I split that 24 packs into portions which are 1 1/3 pack big? Confusing, I know, but I'm sure you'll get your head around it. Meg needs to replace part of her garden fence to keep her dogs safe. She needs to replace 78 feet of fencing. Meg buys fencing measured in metres. Meg uses 1 metre is 3.28 feet. Work out how many metres of fencing Meg needs. So this is similar, so we can think of it as ratio again. So we can have metres and feet. 1 metre is 3.28 feet. We want 78 feet. So how can we get from 3.28 to 78? Or 78 divided by 3.28. Which is 23 point, we'll do it to 2 decimal places, it's 23.78 feet. This is our feet, so this is our 23.78, so that means we need to do the same on this side, but because we're just multiplying it by 1, the answer is going to be 23.78, but it is meters. That's why it's always important to kind of think, what units am I dealing with? So we started off with the feet, we converted it into meters. And finally, question 12. Ria works in a factory making solid steel spheres. She has this information about the number of spheres made each day for the last 100 days. So, number of spheres. So there were 4 days when they made between 210 to 212 spheres. There were 32 days where they made between 213 to 215 spheres, and so on. Ria will use this information to estimate the mean number of spheres made each day. She knows that the volume, V, of a sphere is V equals 4 pi r cubed, all divided by 3, where r is the radius of the sphere. Each sphere has a diameter of 15 millimeters. Then we've got this table down here. So calculate the mean volume of steel used each day to make spheres. Give your answer to the nearest 1,000. Okay, so this volume we've got here. So we can't use this yet because we haven't got our, oh no, we have got our radius. They've given us the diameter, and we know that the radius is the diameter divided by 2. Because if we think about a circle, the radius is halfway across, and the diameter is all the way across. Okay, so the radius is going to be the 15 millimeters divided by 2, which is 7.5 millimeters. So actually we can work out our volume. So this is going to be 4 times pi, which if you look on the front of the paper, it will tell you it's 3.14. R cubed, well the R is 7.5. Now I'm just using a simple calculator, so I'm going to multiply it by itself 3 times, and then when we've got that answer, we're going to divide it all by 3. And let's see what we get. So 4 times 3.14 times 7.5 times 7.5 times 7.5. And we get an answer of 5,298.75, but we need to divide that by 3, which gives us 1,766.25. And what are the units of this? Well, it's volume, and it's in millimeters, so it's going to be millimeters cubed. Okay, now we've got that, which is going to be really helpful, and we're going to use that later on. We want the mean volume of steel. So before we can work out the mean volume of steel, we need to work out the mean number of spheres. So if you remember, we had all this information about how many spheres, but they're split into different groups. We want like an average figure for this. Now, they put that information into this table for us down here. Okay, so we know there were 4 days where they made between 210 and 212 spheres. Well, that's not really precise enough because we don't know, well, were they all 210 made or were 212 made on some days? So what we're going to do is work out a midpoint. So we're going to say, well, let's assume that the number of spheres made was exactly in the middle. And the way we can do that is to take the starting figure, add the ending figure, and then divide by 2 to find the middle. Now you might just be able to look and say, oh, I can see 211 is halfway between, which is fine. But if you can't, or if you want to be sure, then add the two, like the starting point and the end point together, and divide by 2. So 216 plus 218. So we get 217 as the midpoint. And then finally, what have we got? 219 plus 221 divided by 2, 220. Okay, so we're not really interested in this anymore because now we're saying, well, I'm saying that for 4 days they made 211 spheres. I don't care exactly where they came because this is the estimating bit where they asked us to estimate the mean. What they mean is use midpoints. Okay, so if there were 4 days where 211 were made, well, how many were made in total? In other words, we got the days multiplied by the midpoint. So we're going to multiply 4 by 211 So if there were 4 days where 211 spheres were made, that means we made 844 spheres in total. So what we're going to do this is do the same for each of the categories. So 32 times 214, 6,848. 53 times 217 is 11,501, and 11 times 220 is 2,420. Because hopefully you'll remember that to work out the mean, we take the total and divide it by how many, or the frequency. Well, what's the total number of spheres made? Well, it's going to be all of these added together. So 844 plus 6848 plus 11501 and 2420 to give us 20. Something doesn't look quite right there. Let's check that again. 844 plus 6848 plus 11501 plus 2420. No, that is right. 21,613. But that's why it's often good to add these up or give them a look. If it doesn't look right, try it again just to make sure. So we had a total, so this is our total number of spheres made. Need to divide it by how many, well, how many days were there? Well, it's going to be the 4 plus 32 plus 53 plus 11, which they've actually already told us was 100 days, but we're checking. So our mean number of spheres will be 21,613 divided by 100. Which is 216.13 spheres. Okay, now that's how many spheres. They've asked us to calculate the mean volume of steel used to make spheres. So that means we're going to take our number of spheres and multiply it by the amount of steel that we need, which was the 1,766.25 that we calculated at the start. So we've already got that in our calculator. 1,766.25. And we get a big number here, which is 381,739.61. And that's going to be millimeters cubed because it's a volume. It does say give your answer to the nearest 1,000. Well, where are my thousands? Well, this is my 1,000, so I look at the digit afterwards. This is more than 5, so I'm going to round it up to 380. Rounding up, that means that becomes a 382,000 millimeters cubed. Okay. And that's the end of the paper. So quite a tricky way to finish there, but it's a big 6-mark question. So I hope you liked the video. Please like, please subscribe to the channel, have your notifications turned on so you find out when I upload more videos, and hope to see you all again soon. Thank you.